The next talk is already happening. Timmy being eating like he is already coming to stage. Getting mic'd up real quick. I'll do some chit chat while you're being mic'd up. The next talk is by Dr. Kiripanov again on stage. With the warehouse migration they've done together at Cree, high-tech health tech startup, together with Timmy O'Toole, who key part in all of this, and who's now also ready to go. There we go. Brilliant. Here we go. Mike, how about you? You already got yours? Oh, look at that. They've got
wireless.
They both got mics.
Test.
Works. All right, give it up for Kirill and Timmy, please. Thank you.
Yeah, hi everybody once again. So we will talk about the data warehouse migration project that we did at Cree. So as I said this morning, I was involved there for the past year as team lead of the data engineering team. Timmy here is the most senior person in the data engineering team, so he is the architect of the data warehouse. He's actually a medical doctor, trained medical doctor who works as a data engineer. You cannot make this up. Who works for a health company now. Yeah, sometimes karma works out. I need this, I guess. So let me first say a couple of words about Cree. It's a digital health startup that, as you can imagine, benefited a bit from the pandemic. So all of a sudden, people didn't want to wait at doctors' offices, and they were very inclined to try the digital approach. So there comes Cree, which, unicorn. And then they offer an app, so you can see your doctor through an app, but actually they also have physical health clinics. So they really expanded in additional markets. So they operate in the UK, France, Germany as well, but they started in Sweden, so it's a Swedish company. So the app, they try to kind of revolutionize healthcare, and their approach is to try to be really accessible to everybody, to offer personal healthcare, to be proactive, and really putting patient first in their business. So this is the agenda of our talk. So first I'll try to paint the picture and set the stage on the context, how big the company is, how is the team set up, and so on. Then we'll talk about why there was a data warehouse migration project at all. So there were some pain points that were there. And then we'll talk about how we did this in two phases. So first there was a POC MVP phase where we built like an end-to-end pipeline to prove the worth of the new setup. And then, so this lasted about 3 months with 2 data engineers. And then in a second step, we did a full data warehouse migration, which lasted 4 or 5 months, I would say.
Way less.
It started after New Year. Yeah, and we finished in May. 4 or 5
Easter,
months.
come on.
Yeah, there were holidays, people were sick, so effectively it was less. Both of us, yes. And then we'll try to share a few lessons learned, so what we could have done differently, what worked out well, and so on. So let me start by painting the picture. So as I said, the pandemic helped, and all of a sudden Cree has funding. It has 1,000 employees. Out of those who matter are organized in analytics teams. So you have 7 data engineers and about 17 analysts. The interesting bit is that the analysts also work on modeling there. So we try to help them out with the migration to enable them even more. Timmy will talk about that later on. And then the data stack that was in place was Redshift as the database, then Python, Luigi. This is a framework developed by Spotify. Lots of people in Sweden have worked for Spotify and then moved to Cree, so they started using this. And SQL for transformations. And finally, for visualization, Looker is in place, and they do have 300 monthly active users. So a huge part of the organization is actually using data actively. And then the pipeline that was in place was running once per day. So overnight, with the idea that you have the data in the morning ready for consumption. So what were some of the issues? Redshift wasn't great, let's say, so it was getting really, really slow. So the pipeline wasn't finishing for unknown reasons. There was a lot of deadlocks happening all of a sudden. But one of the other interesting pain points were when the pipeline failed, because Redshift is one cluster that Looker was also connected to. And then once you fix the error and you start the pipeline again, this collides with the usage of Looker once people come to work or start working early. And this caused more deadlocks, and it was like super slow. Looker was unusable. Also, the pipeline wouldn't finish, so it was pretty bad. Then there was some system issues. So Cree was a startup, and then you try to focus on value. You try to move fast. You don't worry too much about modeling data and having a nice, robust system. So things were done in that way, but then it blew up, and there was never time invested in fixing things. So we wanted to address some of those bits because it was really necessary. And then finally, and really, really important, is because it's a health data company, and health data is sensitive. No patient wants their data flying around. You have to take care of this. I mean, first, it's nice that you do this, but also for compliance reasons. So because it's Cree an obvious target for compliance agencies and lawsuits. So you really have to make sure that you encrypt the sensitive data, and then you are able to process it and get insights out of it. And then, yeah, moving to the actual migration, I give it up to Timmy here.
There we go. Thanks, Kirill. Basically, I'm not going to iterate or reiterate the schedule, but I'm going to quickly take you through some of the things that went on during the migration. First, the proof of concept, and then the main thing, the main actual finalized move. And I'm going to go relatively quickly because I just want to provide some food for thought. There's a lot of interesting things that went on and some stuff you guys might like to ask about in terms of technical detail about what went on there, but I'm not going to go into too much detail here. So with the proof of concept, I think one interesting thing we did is Kirill initially came to me and said, let's do the minimum possible, or as it said, minimum viable product up there in order to get this over. Let's try and just switch the tables to be in Snowflake. And I came back to you and I said, I'll take responsibility, but we're going to rewrite it all.
Yeah, so one thing that I forgot to mention, in order to fix the Redshift issues, we decided that Snowflake is a good candidate as a replacement database. So it has lots of nice features, not to do a sales pitch for them because they are very good at sales, but also they are very advanced in encrypting and security, so which is very fitting for health data and financial data, one of their main targets that they have. But we can talk about this later as well, why we did.
We can pull up those reasons later on. But I went to Kirill anyway and I said, I'd like to rewrite basically the whole stack with the new proof of concept, because some of the reasons with deadlocks and whatever were due to Redshift, but we had a pipeline that was taking eight hours to run. So it would start off at midnight, and if anything goes wrong and you wake up at 9 a.m. and it's broken and it takes 8 hours to run, it's over now. So, and some of that wasn't Redshift, but some of that was us, causing Redshift to be very bad to us. So we said in terms of a proof of concept is we want to take some small DAG that goes from something we ingest the whole way to something that's being used. Just build that out. Everything, transformation layer, all the different subsystems that we require. And what we said we wanted to do as well, in terms of achieving this proof of concept and showing why it was more valuable to do it in this way, was to really get rid of our legacy code, to really step up our development environment, our CI/CD, turn all of our infrastructure to being represented as code, and put a lot of extra stuff on really validating that the pipeline would run when it was being committed, and also just improve our general SQL. We had tons of SQL lying around, completely unchecked. and simplify and reduce the barrier to entry for basically everything around development, right? So moving on to our proof of concept, we added a lot of extra tech, and this isn't even all of it, but you might as well say we had like a machine running a bunch of stuff that people had bashed SSH'd into and just written stuff on. That's what we had before, and we moved over to Terraform to represent our infrastructure as code, so that we knew exactly what was when, and we could spin it up and we could change it if required in the future. We moved to fully Dockerizing stuff and using ECR and ECS in order to be able to deploy and also deploy clones, and that would help us later on in CI and CD, which I'd be interested to discuss. We added SQL fluff to our process, so as I said, we had no formatting whatsoever on our SQL, and we had a lot of people contributing a lot of SQL. 1,000+ files of SQL, completely unformatted, great. So we added that, and we moved our CI into GitHub Actions. You can see just on the right, I have an example of what a kind of failing pull request might look like nowadays, where you get your standard stuff about some coverage, but then we also brought up the dependency graph for the end user and said, look, you touch this table here, this green one, and that's going to have these downstream effects. So if something breaks downstream, you know that this is how you caused it. And then we have the CI running in completely isolation into an isolated database. And then we're giving a reflection back to our analysts to say, look, if you want this table failed, probably because you took out a column, downstream table. And if you want to check out in Snowflake, you can go and look at that specific subsection, and it's exactly the state that you've caused by doing this pull request. So, as I said before, we didn't want to just do the minimum necessary to move over, but sometimes it's the right time to kill legacy code. And with Crew and all of our large amount of growth, we had a lot of legacy code, and sometimes the only time is now. So we went to the moon with the amount of changes we did here. POC turned out pretty okay, and I would say pretty fast. I'm pretty sure it was shorter than that. I think everything went faster than you say. But when we had our POC, we then had to do the challenge of the next big step, which was getting the whole way over the line with our running code base. And the real challenges we came to with this was that the old pipeline or the old running code was constantly being changed. So we needed some way of developing right to the end and then taking all of the changes that had happened in the lag between when we started and finished and just transferring them on a single day all in one go. Right? We required zero downtime, and basically we had really a lot of code. So I had a quick check this morning, and I was interested to find that our old pipeline had 200,000 lines of code, and by the time we were finished, it was down to about 120,000 lines. So we vastly reduced what was going on there, and we had 1,000+ SQL files. All of these provided significant challenges in terms of even processing that stuff. Right? And then the dialect changes, I think, are very interesting to mention, and we'll talk about those in a second. And a little topic I think is really interesting is when we were transpiling, when we were changing from the Redshift dialect to the SQL dialect, we had to take some interesting approaches to get that work. Okay, and Looker was also a serious challenge. So in terms of transpiling, we used a lot of different tools. We used regex, SQL fluff, caching, multi-threading, idempotent, and in terms of Git, we didn't have too many tools at our disposal. In terms of changing Looker, we didn't have too many tools at our disposal, except for using Git and Looker's self-built-in things. I just wanted to mention, we used SQL fluff to actually transpile all the code, and you can ask me about that later. I'm not going to go into too much detail, but it allowed us to make something a lot more refined than just regexing for, change this function name. We were able to specifically find dialectical sub-elements and then mutate them. I'm going to move through those as well. Just mentioning what's really interesting is we were able to get this the function that transformed all of our code, we really got that to work by taking an idempotent approach and taking every transformation could be run on an already translated file or on a new input file. So in this way, we were able to repeatedly run the same code over and over and over again until we eventually reached the correct state. Once we did everything, we were very happy to find that all of the SQL in our actual warehouse immediately matched. We had some work to do matching processes, which I will not go into. But this was very happy. What wasn't so happy is the last step in terms of moving in Looker. Looker seems very nice, or we noticed that Looker has all the LookML as code. Everything as code is a really nice idea, but the dashboards are not as code. So when we tried to separate out a branch, we were able to fix all the LookML, but we found it was all the same dashboards. So fixing a dashboard for the new set of the pipeline would break it in the old pipeline, which we were very surprised about. And the Looker guys couldn't duplicate any of this code or give us some work environment for that. So we were surprised about that. Moving on, this is Kyril's one again. I talked very fast, right?
Oh, it's, yeah,
Okay.
it's fine. It's the last slide. Yeah. So, what are some of the lessons learned that we had? So, first, and I would say like super important, is to really don't underestimate the SQL migration. So, in theory, it sounds, yeah, you are kind of changing the syntax, you are adapting to Snowflake, but as Timmy said, there was additional challenges here that files were being changed live, and then at some point we needed to bring those changes as well to the final migration. But also it was really difficult to test all these changes because the way the modeling was written, there was a lot of dependencies, so you cannot really independently test certain tasks of the node without influencing a lot of other parts, which made it super difficult to distribute this among multiple people. So we thought, okay, we give it a step of 2 weeks with the 6-7 engineers we had available, but then it turned out you just cannot use 6 engineers. It has to be a very small group. At the end, it was 2 that took this aggressive approach, taking care of this only. Then, yeah, this brought up the importance of proper modeling. So, as I said, Cree, because it was a startup, they started building things really fast. And actually, when Timmy joined, he was the first one that introduced dimensional modeling there. So things weren't really implemented in a nice way, which really made it difficult for, I mean, it's difficult in expanding the data warehouse, extending, adding new features and new entities, but also in this migration, it proved that do proper data modeling, it will save your ass later. Yeah, and finally, communication, as with everything else in life, your family, friends, loved ones, it's super important. And why I'm saying this, that basically when we were migrating things, there were times where things were not available for the rest of the company and for the analysts as well. And it goes a long way if you proactively communicate what you are doing. Even at the beginning, when you start the migration, just proactively saying to the company, hey, we're trying to do this migration, it will bring us to a very good place, the data warehouse will be much more stable and robust, everybody will benefit from this. People understand, you just need to keep them in consideration. There were some bits that Timmy will argue that it's good not to communicate, you just go ahead and do things, so you kind of need to balance it out and see what fits well in your company. So some things you shouldn't open for discussion as well, so lack of communication helps here, but we think that proactively communicating things is super important so that you get like understanding of people if they're not, if things are not working.
Here I talk my slides like a budget rapper and then spend 10 minutes on the last slide.
We have, and with this we give it up for questions.
Sure. I think the transformation layer runs it. The main slowdown that we still have is we're using DMS for actually aggressing the data, and that's a lot faster than it was, but still slows it down by another hour and a half. But we're able to run, we moved up to an SLA of 2 or 3 times a day. Not as fast as we can, but it's like ridiculously faster. 8.
I wanted to ask around this communication part. So I also agree that sometimes it's better to just do something and put people in a position where they don't have the option to voice their opinion. What was the exact thing they chose not to communicate?
Yeah, I think when I make that joke about not communicating, I kind of mean not having a sit-down explanation. It's going to be like this next week. Let's all look at how you'd set up your pipeline or run a query in the new context, sort of thing. I think those meetings would have just led to questions that people asked because there was a meeting, but not because they needed to know. So essentially, we said, look, coming up next week, we're going to force you to switch off the old pipeline in terms of committing, and you're going to commit to the new pipeline. The new pipeline had a ton more checks, really hard, comparatively, to commit your code. It had to be at a really high quality to get it in. Now, this was in the message, but roughly speaking, we didn't babysit anyone through that. We just threw them in the deep end and said, look, come to us, we will help you. But come to us when you have, like, we're not going to have a sit-down meeting to show this. So things like that. We just threw them into the new process, and it's not written here, but we previously had a velocity of like 200, 300 commits a month, and that's already doubled without us having to like train anyone. The code itself set people up to just be able to do it better. We focused on that rather than having meetings to tell them about how the code might help them to do it. That's the thing in terms of this over-communication stuff.
Just interested in hearing about the anonymization.
Yeah, in terms of that, Snowflake was we really want to move to Snowflake. That was a really primary driver. In the old world before this, our data warehouse also, we just didn't bring stuff in if we were worried that it might have problems. And Redshift, I think, really does have access control problems that are pretty serious. It's quite straightforward. There are the encryption keys. There are encryption keys at multiple tiers in Snowflake. They live outside of Snowflake, so coupling. One of them lives at Amazon, one of them at Snowflake. And I won't talk about the kind of lower tiers, but the highest tier of encryption, we're literally using Lambda functions to encrypt those columns. So it's quite expensive, but what we can do, although we haven't fully implemented, is have a request to say, I need to access this column, and this column is encrypted. So that request links to temporary access. That temporary access has logged queries, and if those logged queries were, in theory, doing something that it was supposed to do, we would see it. And the access keys to decrypt is only given when access for a specific column requiring those keys.
One short last question.
Right? POC production. Those business. Unclear for the business use.
Well, that was Kyril's job, but I could argue it was very clear here. We had major security concerns with our general way of working, and there was a company-wide push because of Schrems 2 legally coming through that we needed to have really solid encryption that could justify our behaviors with. So that instantly justified it, and it was even with the core beliefs of patient first. But yeah, everything was grinding to a halt. Redshift. Pipeline couldn't be repaired if it went down. It takes 8 hours. All of these things went away.
Legal problems saved you a bit here. Don't have a legal.
No.
Might be a bit more.
Yeah, but if the data is not there, if people have problems, you have days where you have only the data up to the day before, people start noticing this and they complain. So there is value in improving your setup because you will have fresher data available. And this is a good enough driver to push forward. Also, it's very important to mention that it wasn't that the team stopped doing anything else on the old pipeline. So we kind of split the team in the POC part. It was 2 people only working on the POC. The rest were business as usual. And then even in the next phase, I mean, more people were chipping in with help, but we had some bandwidth on serving the business at the same time. So it was kind of doing things in parallel that you have still, you're offering services to the rest of the company, but you we managed to convince people to give us this time to fix things.
But I think it's a really good point in terms of business acumen as well, because when I saw the encryption, in all honesty, when I saw the encryption being a serious concern, I said to Kirill, we're changing everything. I stole the time based on the obvious necessity. I saw and predicted and didn't have to negotiate that all of the rest of it would be beneficial. We had the mandate to fix the security. You know, we'll just fix everything.
Speaking of time, get out of it. Thanks again to Timmy and Kirill. This was amazing.